Okay, good evening. So I'm really glad to see many people here in this class. You realize that there is a very important subject we are going to cover today. And the subject is SQL or SQL. It's up to you how you pronounce it. It doesn't matter. Okay, both versions are okay. So this is very important subject, of paramount importance. Okay, the reason is that databases and SQL are used everywhere in every company. And as such, if you go to any company for an interview, definitely you'll be asked questions about SQL. I'll just bet that the probability will be probably 99%. Okay, so for that reason alone, you have to know it. Okay, but besides that, you may encounter the need of SQL, knowledge of SQL in many other situations. We are going to cover that. So this class is for QA engineers, SQL for QA engineers. That's what the title is. So I try to adjust that for the QA engineer needs. So the amount of information which I put in the slides and I'm presenting during these two classes is more than enough, okay, for you to have basic knowledge of SQL and be able to pass an interview. But it's definitely not enough, amount of time to practice it and then to learn it to the level which you need, okay? So it means that you have to practice at home yourself, okay? I have books available and I have materials available, so I encourage you to do that, because just sitting in a class and listening and then a couple of keystrokes would not be much help. Definitely you will understand the principles, but you would not be able to do it on an interview. On an interview, they will definitely ask you to put something, to write some statements, okay, not just general principles how the databases operate, okay. They will say, let's assume we have a table, how you're going to fish out information out of this table. That's a typical question which will be asked on the interview. Any question? Okay, let's start. So SQL stands for scarcely qualified as a language. Now this is joke, okay? This is joke, but if you compare with other languages, C++ or Java, that might be a very simple language, but nevertheless it's a full language. So it stands for structured query language, okay? That's what the abbreviation stands for. And it's as I may say, it's a query language, but it's actually not exactly query. So you can do much more than just simple query, okay? You can do a lot of other activities. So these are class objectives. You should be able to understand how information is stored in a database and retrieved with SQL. We're talking about relational databases here. You should be able to execute SQL queries. We're talking about practical SQL. We're going to learn SQL and database operations, basics, and terminology, which is very important. And you should be able to answer interview questions, also last but not least. So what is a SQL? This is official definition, but basically SQL is a language which allows you to retrieve information from the databases, insert information, update, delete, create databases, create schemas, and so on, and do a lot of, and manage the databases in general. Okay. So where a QA engineer will face the necessity to know SQL language, there's some situations which are listed here. First of all, you will probably need to get data for testing purposes. Okay, for example, let's assume you're working some applications and that application stores a lot of information in a database. In order to test the application, you need some data, right? So where to find it? Most probably in the database. You probably need to modify that data, but most of the, after all, you have to get that data out of a database. So saving data generated during testing activities, especially during automated test cases. When you run test cases automatically, you like to save this data somewhere, right? You can definitely store the information in a text files, but that's not convenient, because with the time, number of test files will grow. That will be very difficult to navigate and get information out of these test results files. So if you store information in a database, then it's no problem. Okay, you can easily fish out information when a particular test case was run, and the result of the test case, and even information about suites and so on. It's very useful. Okay. And data verification in databases, you might find yourself in the role of testing the database, how the database is designed and how data is stored in a database without corruption, without compromising the integrity, and so on. Okay, then you definitely need to know SQL language, because if you don't know, then it will be very problematic to do that. And then testing databases in general. The basic, there's a few activities. This is not complete list, and let's start. Again, we are going to talk about relational databases, not just all databases, but relational databases occupy probably 95% of our market. Okay, so most probably you'll face relational databases. So imagine that we're working with Excel spreadsheet, okay, and this is the typical spreadsheet, how the spreadsheet may look like. And then I need to store the following information. I need to store information about the person's first name, last name, and gender. So I created these columns, okay, in the Excel spreadsheet. I call it first name, and I observe here that I can have space between in titles. I created first name with a space, last name with a space, and sex as a third column. And then I keep adding information. Probably you done that many times with Excel spreadsheet, so it's nothing new for you here. So and then if I need to add new person, then I definitely add at the end of the spreadsheet, and so spreadsheet grows actually vertically. Okay, so nothing new for you here. And here's another table which is definitely bigger, and in this case I'm storing information, a social security number. We store information about the first name. Observe that there is no space here. Last name, address, city, and state. Okay. And then number of columns might be bigger, might be say 30, 90, whatever, 100, 200 columns. Bigger, more columns I have, more difficult it will be for visually inspect the information, scrolling to the right, to the left. And also, if I'm keeping information about large number of people, then this table will be huge. Okay, the spreadsheet will be huge. Okay. Now, talking about the database terminology. Row, now what we used to say row, now it's called record, okay, and column is called field, and we are going to use that terminology. And also we are going to talk about the schema, because databases is more than just collection of tables. Okay, it collects other objects. We are going to talk about them later during this class. Okay, triggers, views, and so on. And records which we add to the tables are not stored in a database in ordered form. Basically, they're not stored. Okay, there is no specific order where we add records. Pretty much like if we add new person here, for example, if I add another person with the name Anna, I'm not going to squeeze new Anna into this somewhere between Anna and Boris. I'm basically adding at the end of this table. Okay, so table grows vertically. Said that, next question which I'm going to address to the class is that what happens if a new record is added to the table, and we are going to talk about this table. Okay, what happens with this table if I add another person with exactly the same first name, last name, and gender. Okay, let's say basically we are going to have exactly the same values as existing one. So a question is this a problem? And if this is a problem, how we're going to solve it? And if it's not a problem, we just keep going. Okay, so I'd like to hear your opinion. What do you think? It's a problem, okay? Not a problem? Okay. Problem. Okay, we are going to vote, okay? People on the back row are the smartest one, okay? Actually, yes, it depends. Because when you are going to answer any questions related to the table, the question number one should be, what is this table for? Okay, why we created this table and what purpose it serves. Okay, without answering that question, we could not answer many other questions related to that table. Okay, so and we have to address that question. We have to ask that question, and then the answer will be the following: if this table is designed just to keep counting of people who actually visited, say, football game or visited some special event or something like that, then it's not a problem. As soon as number of records here in this table matches actual number of people, there's no problem, because we don't care actually if it will be several people sharing the same exactly the same information in each all fields. Okay, it's not a big deal. However, if we're trying to track people who attending a specific course at a college, for example, and or getting medical help, then it's a problem, because we like to be able to distinguish, we like to make sure that each person listed here is unique, okay? So in that case, that's a problem, correct? So in that case, we are going to solve this problem somehow. So how I'm going to solve this is I'm going to introduce additional field here, which I called ID, and then I'm going to put numbers here. And I just like to make sure that each person listed in this table has unique ID. Okay, basically these numbers which are listed in this field are not repeating. You cannot find the duplicates here. So basically each number listed here is unique. Most easy way to do that is just generate a sequence of numbers and just put here, right? Like in this case, I started with number 1. I use integers, whole numbers, and then just keep adding. As soon as a new person is added, we just keep incrementing this value which is stored in ID field. Okay. In that case, we are guaranteed that there are no two people with the same IDs, even if their first name are the same, last names are the same, and gender is the same. Okay. There's absolutely no way we can mix actually two people together. And that's what indeed is done in reality if we like to make each record unique. So what we done actually, we added a uniqueness to the records. We just made each record unique and easily identifiable. And what is said in database terminology, we created primary key, or PK, or ID. They are all synonyms. Abbreviation is PK, two letters, PK, or ID to the table. Okay. And then if we're going back to the table, the question is, what is the PK for this table? We can say PK is ID field, okay? Because this field makes a record unique, okay? So sometimes they may actually create two tables, and the combination of two values from these two actually create another field, and combination of values in two fields make record unique, okay? So it means that if you don't see primary key defined, it does not mean that the records cannot be uniquely identified, okay? Sometimes done differently, but the main idea is that we should be able to identify each record uniquely, okay? So there will be absolutely no duplicates. And that's, in a simple way to do that is just add another field and then put unique values here. So values here might not necessarily to be integers. It might be long numbers, it might be images, it might be fingerprints and whatever, okay? As soon as the value what you put here is unique, okay? Whatever you put, it's not crucial, okay? So said that, now we are going to have a table which contains so-called duplicates, in quotes. We have two Anna Razguls. This should be female here, so it's a typo, sorry. So we have two Anna Razguls here, but we can identify who is who by their IDs, okay? Because first Anna Razgul has ID 1, her primary key for that record is 1, and second Anna Razgul has ID 4, that's her primary key for that record. The key for that record is ID is 4, okay? So we can say which Anna Razgul, and then you can say either 1 or 4. But there will be absolutely no possibility to mix them together, okay? Because they have something which allows us to uniquely identify, to distinguish between them, okay? And definitely we can put images with the faces here too, right? That will work, right? So in that case, if you look at the images, say, yeah, this is this Anna Razgul, here is another Razgul, okay? Okay, so what we did actually, we created two-dimensional, talking about records and fields, table of information. And this is actually building block for any relational databases. Doesn't matter which database you take, the basic building block still will be this two-dimensional table. Okay, so we're going to, it's very close relationship with the Excel spreadsheet. Actually, Excel spreadsheet is a database itself. So you can retrieve information from Excel spreadsheet programmatically using SQL. Okay. So, but Excel spreadsheet is good for a reason that you visually see the data. You can punch the data and you can visually inspect the data. Okay. Now this table becoming more complicated in the sense that I need to store now contact information for these people. So definitely I'm able to distinguish between two Anna Razguls, and I can find out looking visually inspecting this table visually, because we haven't learned how to do it programmatically yet. Okay. So I can visually inspect this table and find out the Anna Razgul's phone number here, which is 111, whatever. and the second unarousable phone number, which is different. And then if I ask a question, so for example, what is unarousable number 4 phone number, you can easily find out that information saying, you know what, let's find ID 4, this is unarousable, just, and then this is her phone number. We can also do reverse phone lookup, like for example, if you have phone number at hand, you can find out whom this phone number belongs to. Okay, so that's also possible. If I give you phone number 222 and then 2222, whatever, all twos, you can go and look at the phone number, field here, find out this phone number, going back here, say this is Boris Gurich, which with ID 2. Okay, so that's also possible. Now, when the information starts to grow, for example, and then the situation becomes a little bit more complicated. For example, what's the problem with this page? There might be a potential problem here.
One person might have more than one phone.
Exactly. So what nowadays people have several phone numbers they can be contacted to. And then you may have ground phone line, and then you may have cell phone, you may have office phone, and so on. Basically, let's say three phone numbers in each person. How are we going to put this information into this table? So we can create several fields, right? We can create, say, for example, cell phone. We can create a field, say, ground line, and we can create a field office phone number. Okay. But not all people have all 3 phone numbers, right? Some people may only use cell phone and then don't care about the rest, okay? So in that case, we still need to create this field for them, but values in these fields will be empty. We do not provide any values for this field. So basically, we are probably going to waste some space, right? So how to solve this problem? Because, you know, it's okay if you have 4 or 5 people in the database, but if you have 5 million people, then the storage waste will be significant. Okay, you simply cannot ignore that. So what we can do here, we can actually cut this field here and put into a separate table. Okay, like let's go back. Before doing that, I also would like to demonstrate. Another solution, you may think that if we keep listing all cell phones separated by commas here, okay? Like for example, assuming that this is a cell, we can say cell, column, and then list this number, and then semicolon, saying specifying office and so on. Okay. I faced this approach actually once. That was a bug in a database. What happens is that I was working in a company, and the company had a policy of giving out the cell phone numbers to all employees. So basically, all employees, they had company cell phones. And the company also kept directory of all employees. That was a LDAP directory. And then over there, personal information were listed for all employees. And also at some moment of time, they offered to synchronize cell phones with the company directory. So that was very easy. So if you need to contact some of your coworker, that will be very easy to do. Just simply, all employees will be in your phone book. So basically, find out the person name and then dial. But one of my coworkers, he had 3 cell phones. Okay, historically it turned out that way. One was his personal, another one was a present from his mother, so he used to communicate exclusively with her mother. I don't know why. And the third one was a company cell phone. Okay, I don't know how he managed to charge them, because charging one cell phone is already a problem. Okay, charging 3 phones, keeping them alive, that's a problem of itself. But what happens is that in a company's directory, when you go to the website of the company, you could see his cell phone numbers listed, separated by commas. And this is not a problem, because you realize that this person can be contacted by one of these numbers, okay, listed there. And definitely you take a cell phone or phone and dial any number you like. But when this directory were transferred into the cell phones actually listed all, the cell phone directory or database, they listed all these cell phones separated by comma as it was in the company directory. So anytime you like to dial him, the cell phone actually dialed all his numbers, 3 numbers, all together. Not one at a time, but just all together, and then put in comma for delay, say 2 seconds delay. And the result is that we never could reach that person if we just directly dialed his number from the phone book. Okay, it didn't work because cell phone tried to dial 3 numbers one after each other. So we had to write down his cell phone number, one of his cell phone numbers, and then dial manually. Okay, this happened because the value which is specified in individual cell is regarded as an atomic one. You cannot split it anymore. Database regarded that way. Okay, so for you that might be actually listing of several phone numbers separated by some delimiter. That's how you see that, but the database sees that completely differently. It says, you know, whatever you put here is atomic value which is not divisible, and we cannot split it. Okay, so that's why database actually dialed these numbers one after each other. So this is not a solution either. Okay, we cannot squeeze several phone numbers. Technically we can do that, but we cannot fish out the individual value out of that. So solution is that we should split this table into the two. Another problem might be if you go to the example of database. This is simplified the database table from the bank. Okay, assuming that the bank keeps information about the purchases made, this table may look like this. Okay, so in this table we list personal first name and last name of person, a credit card number which belongs to that person, and also the purchase date made with this credit card, and the purchase amount and the sale point. Essentially, that's how it looks like. And then you realize that this table will grow drastically because a lot of people making purchases. So this actual table will be too big to inspect it visually. Now the trick is that if, for example, several people making some people make several purchases a day, which is not unusual situation. Like for example, if we are talking about Vlad Mlad and Peter Leko, we realize that this information is going to be added to this table as shown here, right? You see that Vlad Mlad made a purchase on 24th of February, say at some time, and then next purchase was also made the same card number. Okay, it should be same card number. Now, you realize that these tables actually can be split into two parts. One part will keep information about personal information like first name and last name and maybe credit card number. Second part will keep information about the purchases made. Why we need to split this table? Because this table, these two parts of this table, which right now it's consisting of one unit, actually growing with a different speed. Number of purchases made definitely greatly exceeds the number of customers added, okay, to the bank. Basically, people make more purchases than new customers come to the bank. Definitely, that will be dream of every bank, that if number of new people and new customers go to that bank with the same speed, but it's not the case. So what happens here is that if we keep information about the purchases made in this table, in this format, we're actually repeating this information. You see that we have Peter Leko here, and every time that person is making purchase, we're basically populating these two fields with the same redundant information. Okay, we don't need that. We basically like to keep these two pieces of information separately. Say create one table which is say Peter Leko and then his credit card number. That will be it. Second table will contain information about the credit card number and purchase made with that credit card number. So basically, we balancing the load. Okay, we're just actually splitting the table into two parts because they grow with different speed, and then this will allow definitely to improve the performance of the database. Okay, that's what we're going to do. That we are going to split this table on this credit card number. So basically, credit card number will be listed in this first table. That will be first name, last name, and credit card number. Second table will contain credit card number and purchase date, purchase amount, and sale point. This one. Okay. So definitely they will share the credit card number information will be located in both tables, but they will grow with a different speed. Okay. That will actually allow us to perform to improve the performance. Besides that, we eliminate the necessity of storing redundant information here. Okay, which is not good because that's a waste of space. Okay, so talking about the database language, we do normalization. Okay, it says that the table is normalized. This table is not normalized. Okay, when we split it, so we allow to the balance the table, then we say the table is normalized. Okay, that's a very important aspect of database design. Fortunately, you will not be involved in that because QA engineers typically are not involved with this activity, but at least you should understand the principle of what is behind this. Okay, so why normalization is kind of a not good term, but it was coined in 1970s when normalization was very big, very popular among politicians at that time. So it comes from politics actually, not from database world. Okay. So this is explanation of what we already said. And then what we need to do, we need to create several tables, each serving its own purpose. And these tables, you may assume that they are logically linked to each other, right? Because if I create a table with the first and last name and the credit card number, and then I create another table with credit card number, purchase made, and purchase date and amount, this table kind of a link together because that credit card which purchase was made with links to the real person, right? Credit card cannot exist without human being, okay? The other statement is otherwise also valid, okay? Because people cannot live nowadays without credit card, okay? So this is actually, we have symbiosis among these two. Okay, so what I'm doing here, I'm creating another table. We are going back to the table with personal information and phone numbers, which we started with. And I created this table where I have following fields. This should be one word, okay? It's basically split into two rows, but it should be one word. So I have entry number, which is my primary key here, okay? This field, entry number, allows me uniquely identify all records in this table. So this is a primary key. I have owner ID, which is listing the IDs of personal IDs from the first table. I have phone number and then phone type. So what happens here is that this table is exclusively busy with storing phone numbers, okay, contact information of people. It has nothing to do with first name, last name, gender, and whatsoever. But you may realize that this table is related to people, right? Because people, actually, the phone numbers belong to the people, okay? So the reverse statement is also true, okay? Some people also cannot live without cell phones. Now, what happens here is that this owner ID, though named differently, but nevertheless it contains information which also listed in the first table, because this owner ID is ID field in the people, okay? For example, we listed first name and last name. So that's how these two tables are related to each other. This is schematically shown here. This field should not be here. This is error here. But what happens here is that, for example, if I need to know this phone number, whom this phone number belongs to, this 1111, I can grab the owner ID, which is 1, with 1 at hand, come to this table, first one, and look at the ID 1, and I find out this is owner as goals. This, again, this should not be here, because this information is transferred into this table, okay? So, and then in that case, we can list as many phone numbers as we need, and then if person has 10 cell phone numbers, we don't need to create 10 fields here. We basically add another records here, another 10 records here. So in that case, we can find out actual information. Direct or reverse phone lookup, it can be easily performed here in this case, okay? But again, information now is scattered across two tables, okay? But nevertheless, we'll be able to retrieve this information even if it's scattered. In some cases, information might be scattered in 10 different tables, okay? Retrieving this information is definitely more difficult, but it does not mean it's not possible. That's what it's done in practice, okay? But doing that, storing information to tables, actually I balance the load. So basically, I normalize these two tables, which improves the performance of the database drastically, okay? Any questions? Okay, should be clear. So that's how the information is retrieved, schematically shown with the red arrow. And so what happens here is this, in this case. So we have two tables with the primary keys defined. In one case, it's ID. ID is a primary key in first table. And entry or phone number of whatever is entry number. That's called entry number. Maybe not good name, but nevertheless, entry number is a primary key in this table, okay? So what happens here is that typical examples of primary key which we can use social security number, which is overabused or overused in this country. We use it everywhere, every possible case. We can also use driver license ID if we are talking about local state information about locally. Okay, there is no need. I mean, there is no possibility of overlap. Also, instead of primary key, we use identifier or just ID. Okay, they are all synonyms. Now, these are primary key here. This is primary key here. So you realize that owner ID also lists the information which is listed in the first table, but this information is in the primary key field, correct? Information which is listed in this table, this might be called differently, it doesn't matter, but the information which is stored here is the same, but it's repeating here. You see that because Anna Razgul may have 3 cell phone numbers or 3 phone numbers, and as such, we're going to have 3 entries in this table with the same owner ID belonging to person number 1. Yes?
So there is a pathway that is defined that connects the 2 tables together?
No, actually, no.
So how does the database know where to look for the information?
Database does not know that. You have to tell database, okay? You can look at the database design. For example, it's schematically shown, then you can see the links, but you don't draw the links directly into the table, saying, you know what, now it's connected to that one. So these 2 tables actually physically are not related, but logically they are related to each other. So by virtue of the values, not by name of the field, for example, field names are different, but the values which are stored here, okay? Because this value 3 belongs to Sri Lakshmi, right, for example, and in that case, definitely, you see that there is a relationship between this table, but no more than the virtue of the values, okay, stored. Now, values which are stored in this field are unique because this is a primary key. Values which stored here, they are same values, but they are repeating. And as soon as they are repeating, they cannot serve as a primary key here, right? Because we cannot uniquely identify a phone number by this value here because it might be repeating. So it is said that this field, owner ID, is a foreign key. We have primary key and a foreign key. So owner ID here is a foreign key. Okay? So you may have any number of foreign key in the table. You are not limited to that, but in this particular case we have only one owner ID, which is a foreign key. And this foreign key points to this ID primary key here. Okay? So you can find out this information. Typically when they create a table, they indicate that foreign keys and primary key. Otherwise, it will be very difficult to navigate through the database table, especially if you have many, say, thousands of different tables. But you link these 2 tables logically, okay, by virtue of the values stored in these tables. Okay? So, and then we'll talk about finding values. Definitely, this describes how you're going to find out phone number which belongs to a specific person, the direct phone lookup, and also you can do reverse lookup. Okay. Right now, it's a several-step process, but in reality, it can be done immediately with one query. Okay, we're going to see how to do that. So, and then the relationship again is shown here in these 2 tables. Now. This is the definition of foreign key, which we already said, foreign key and primary key. And then we can link these 2 tables by primary key, foreign key relationship, but that's not the only way you can link 2 tables together. Okay? This is probably most widely used and most straightforward way, but that's not the only way you can actually retrieve information from 2 tables, 2 or more tables. Okay? Now, it's time to do practical SQL. It's time to do retrieve information using SQL programmatically, but we need to learn SQL first, right, in order to be able to do that. So, why SQL and why Oracle and not other relational database? What is the necessity of choosing Oracle? The reason is that there are free databases, relational databases available for download and installation. You can use Microsoft SQL Server. There is a free edition of that, Express edition, and you can use MySQL, for example, okay? And you can use Oracle. So Oracle is good for several reasons. First of all, it comes with the interface, so it means that you don't need to install an additional application. You can download Toad application and install it, but this version of the SQL Oracle 10G Express Edition comes with the interface, so there is no need to install and configure a second application. Second is that this Oracle database comes with the sample data. Basically, it comes with a table populated with the data, which is makes life much easier. Instead of sitting and punching data into the database and playing with that data, this database already comes with the data in it, okay, with the personal information, with some location, and so on. So it's easy, it makes your life much easier. If you install MySQL, you have to install some application, which is a visual interface to that database, because you are learning, you need to have some graphical application, and it doesn't come with any sample data. Okay, that's bad. In the case of Microsoft SQL Server, you can download sample database, which is called Adventure Star database. It's freely downloadable from Microsoft site, but also you need to install the interface, which is called Microsoft Management Studio. Essentially, you need to download three different pieces and install and configure that. Okay, so if you have strong desire to work with the Microsoft SQL Server, no problem. All principles and all information which we are going to present during this class fully applicable to the Microsoft SQL Server, with slightly deviation in syntax, but the majority of the information is applicable. So it's up to you. Okay, but we decided to take Oracle, and in order to talk to Oracle, we definitely need to learn SQL. So here, how Oracle is working in a nutshell, just in a very brief introduction. Yes, go ahead.
What does a relative database mean?
Relational database? Okay. So that's a very good question. Let's go back to this one. Okay. So that's a question which may be asked on the interview, but besides that, definitely it's interesting for you. So a lot of people believe that database is called relational because we have tables which are related to each other. Right? That's a very simplistic explanation of it, but it's not the case. Okay, it's not true. The reason is that database may contain only one table, but still we were relational, right? So adding more table would not change the nature of the database, or removing table would not change the nature of the database. The reason for calling relational is that each individual field contains information which is related to each other, because, for example, Razgul, last name Razgul, belongs to Anna, and female also belongs to her, as well as ID1. They are related to each other. That's why it's called relational, not because you have several tables. Okay, so we don't dump all information in one place. Okay, so we also have non-relational databases where you're allowed to store, for example, non-atomic values here, and then basically objects here. That's a different story. But again, that database may also contain one table and be either relational or non-relational. Okay, that's not a relationship between several tables which makes the database relational. But this is actually very big, widely spread misconception. Okay, a lot of people believe that relational is called because we have two or more tables which are related. It's not. Okay, that's a very simplistic explanation. That's a wrong explanation. Okay, I think yes. Go ahead.
I have one more question
Sure.
about four forms of database, relational database.
Forms?
Forms, first form, second form, and third form. I heard about it.
First normal, second normal, or something like that. Normalization.
Normalization. Yeah, normalization. Okay. So this is actually handling with the database design. Okay. So for you to know, is just this is normalization, which we split information into the spread into several tables, two or more tables, just to balance the load. But also we pay the price, because in order to gather information from several tables, it takes time, right? So sometimes table is not normalized, okay, at all. We know that we violate the balancing rules, but we need to get speed. Okay, in that case, the table is not normalized. But in that case, you have all information. For example, as we agreed, we have first name, last name, gender, phone number 1, phone number 2, and so on, stored in one table. In that case, you can easily you can retrieve information faster than in the case of this one, okay? But you'll pay the price. That will be the load, okay? Yes?
How you would normalize table?
You have to remove fields and add to other tables. Basically, you have to design. This normalization of database table happens at the design time, not at the database information retrieval time, okay? When you're sitting and designing database, that happens there at that time, okay? Or later on, if you need to say, okay, wait a sec, this table is not normalized, you can split that, but that will be, you'll pay the cost, because if everything is set, a system is set up over retrieval of information, and then suddenly you change all this, the design, you have to change a lot of stuff, okay? So that's what I'm saying. Typically, it's done during the design time. Okay? Yes?
So this is an example of first level of normalization?
I cannot answer that. Okay, I have to look. Okay, yeah, I have to look into that. But I presented the way of what normalization is. Okay, I have to confirm that with the, look at the book. I don't remember that. Okay, any other questions? Okay, so as soon as there are no questions, we are going to Oracle. Okay. Oracle, in order to connect to the Oracle and work with the Oracle, you definitely have to have a username and password. Basically, you have to have an account at Oracle. And before you do anything with the Oracle, you have to be identified. Okay, that's why you need your username and password. And then database administrator decides which roles and privileges you have. Okay, so because you may have different privileges with different access roles and so on. And when user logs into this Oracle, it's said that he established a session or connection, there are synonyms, and you may establish more than one connection if you need to connect to the Oracle. Okay, so don't think that you're limited to only one connection. Okay, but all the activity are tracked. Okay, so that's by design. Okay, whatever you do with the database, this information is tracked. Okay, so let's do that. Let's go to the database, which we have installed on every laptop in the class. Okay, and let's do it together. Oracle, let's see, Oracle. You click on the Oracle Database 10G Express Edition. Under that, you have go to the database homepage link. Click on that. And as soon as you click on that, you'll see the browser is loading, navigating to the Oracle database page. Do you see this page? Okay, so what you do, you go to the Start menu, select Oracle Database 10G Express Edition, and select Go to Database Home Page. Okay, when you log in as a HR, you see these buttons here appearing on the screen. So what we are going to do, administration is for database administration. We are not going to alter anything here. We are going to work with the object browser. We are going to work with the SQL. We are not going to work with utilities, which are for database backup and restore. We don't need that. And if you need to create an application, for example, your own applications, you can do that. These are actually Java applets. We are not going to work with this either. Okay, you can explore it at home. You can free of creating your own applications on top of a database. That's perfectly okay, but we are not exploring it. So what we need to do now, we are going to object browser to see what this database contains. Okay, so clicking object browser will show us this interface, and by default it shows tables. And then if you click on the tables, you'll see that we have more objects in this database. So all these objects are actually visible for user HR. So that's actually a visual representation of schema. Okay, remember we have schema, which is more than tables. Here's what objects actually contribute to the HR schema. But default one is the first one is the tables, and we are going to explore these tables. So this database contains, I believe, more than 50 different tables, but only 7 of them are available for user HR. Other tables are not available because they are for administration, for other purposes, and user HR does not have privileges of accessing them. But user HR can see these tables, and these are tables, 7 tables. What we are going to do, we are going to see how tables are created, how they are designed, and what we should expect in these tables. So the very first tables which I'm going to click is employees. That's probably table number 1, primary interest for human resources, right? So I click employees, and here's the information about this particular table appears here. So we're going to explore that, and we're going to discuss what kind of data this table contains. Okay? So what we have here, we have listing of fields, essentially columns if we are talking about Excel spreadsheet. So we should expect to see a field which is called employee ID, which is primary key here. You see this primary key 1. This is a primary key for this table. So it means that employee ID should contain unique values. Okay. Now, employee ID is data type, essentially the type of information it can contain is set to number. It means that we should expect to see numbers there. But what kind of numbers are explained in these parentheses? This is called precision and size. Okay, so we expect to see 6 digits with the 0 decimal points. Okay, so basically we are going to see integers. That's maximum value is 6 digits. Okay, it might be less, but nevertheless that would be it. Another property of this field is called nullable. Nullable means, are we allowed to drop this and to not specify this value? For example, if I'm entering new employee, can I skip specifying his primary key? And by default it says, no, obviously it says no, because if we say yes, and then several of the employees' values are dropped, then we have a violation of uniqueness, right? So in that case, definitely should be no. After that, we are going to have column first name, which is, say, varchar2. Okay, varchar stands for variable character length, all the way up to 20 characters. It means that we can specify any name up to 20 characters long. Okay, and is it nullable? It says yes. So it means that if we like, we can skip first name. This is a first glance. Maybe there are other restrictions which will not allow us to do that. If this database table designed as is with no other restrictions, then we're allowed to not specify first name. So basically, we can skip specifying employee's first name. Okay. We also have a last name field, which is a varchar 25. And in this case, you may assume we can specify variable character, variable string, variable up to 25 character long. Okay. And it's not nullable. Well, we have email, which is varchar 25. We are going to have phone number, which is also varchar. We are going to have hire date, which is a type of date. So basically, in this field, we are going to store dates. Okay. Job ID, which is varchar 10. We are going to have salary, which is the number 82. It means that the total number of digits is 8, but 2 digits are reserved for the decimal. So basically, it means that the integral part is 6 digits. 8 minus 2 is 6. Okay. Commission percentage, which is 2.22, it means that we are going to have, you should tell me what we are going to see here. Sorry? No. This 2.2, what does it mean?
Only decimal values.
All the decimal values. We are not going to see any integral part there. Okay, so decimal values. And then manager ID is a number, again 60, and department ID is number 40. Okay, that's what it is. This is actually how the table should look like, from structural point of view, by design. Okay, but this is not actual data which is stored in this table. Okay, any questions?
Why varchar 2?
Oh, varchar 2? That's a good question we should address to Oracle. Okay, because they have varchar. So what happens is that they have a data type which is called char, C-H-A-R, and then they decided to introduce varchar. But then they say, okay, we have varchar, and that's in future it may change, so they decided to do varchar 2. Okay, now mostly nowadays they use varchar 2 and they don't use varchar. You can use varchar, it would not be different. But that's actually kind of a it's a very strange situation, because they created something, some data type for future use. They're using it now, but now they don't distinguish between varchar and varchar2. There's absolutely no distinction between them, okay? They may change in the future, but that story comes, I mean, last maybe say 6 years at least, okay, if not more. So far no changes. So to be on the safer side, use varchar2 and forget about the difference, okay? And no one knows why exactly we have these two data types which is exactly the same. I don't know, okay? And there's some things which always, you definitely like to ask Oracle why they do this way or not the other, okay? There's actually no logic behind that, but we have to live with that. Any other questions? No, okay? So if there are no questions, let's move forward and see what actual data this table contains. So in order to do that, basically you need to click on this tab, which is called data. Okay, because by default we are located on the top table. If we are going to data, which is highlighted now, let's click on the data. And this will show the actual values stored behind in this table. Okay? Well located in the data. What you need to do now is just spend several minutes making sure that the information which is listed here actually matches the database table design. And if there is a mismatch, then we have to log a bug against Oracle. That's the first thing we should do.
I like
First guy? Why?
nice name, last name, and first name.
I thought you would say it. I would say he has a very good salary here, right? But okay, it's up to you.
For commission percentage, we have 0.4 instead of 0.40.
That's okay. You can specify with the lesser digits. It's the number is actually, I mean, the size specify total maximum. Okay, but you can specify less. Same with the salary. We can specify salary with the maximum 2 digits of two decimal digits, right? But we can skip that too, right? We can actually skip specifying decimal digits if we like. There's no error here. Okay, what's the verdict? Any discrepancies found? Yes, go ahead.
Email address.
Okay.
It doesn't say anything whether Gmail, Yahoo, something.
Yeah, it's a username, more username than email, because the domain will be that companyname.com most probably, and then they decided to skip that repetition of that domain, because if you know the username, it's easy to reconstruct email if needed. Okay, they decided to store in that format. Looks okay, right? Okay. So the only thing is that whenever you see these dashes, this is actually very bad design. These are actually not dashes which are stored in a database. This basically is empty and nothing there. Okay, but they didn't like to show the nothing or saying there is no value or NA, whatever. They specify dashes, but in reality, you should realize that the no value specified is basically a vacuum in a database for these values. Okay, this is actually somewhat misleading. But generally speaking, this database, I mean the values which we store in this table, matching the designed one, right? In general. Okay, sounds good. So far, so good. Let's go and see what's next. Next, we log into the database. We went to the table design and to observe that pretty much the same way we can explore locations. We can explore other tables here, which is available for user HR. And again, there should be a match between the database, I mean the design and the values which we store in a particular table. In this case, in the case of locations, we have 4 fields here. We have location ID, which is a primary key. We have street address, which is a varchar. I don't know, it might be varchar 50. We have postal code, which is also varchar maybe 10. And we have city, which might be varchar 10. Okay, but you have to look at that. Okay, I don't remember, I don't keep that in memory. But we have 4 fields here. Okay, so far so good. So now time to retrieve this information programmatically. Okay, so we have to use SQL in order to retrieve information from database table, because table might be huge. For example, in this particular case, table may contain several dozens of records, but if you have, say, a couple of millions of records, you have absolutely no chance even to visually inspect. You cannot scroll up and down, because every scroll will take maybe, say, 10-15 minutes. Okay, so it's not practical to do that visually, so we have to learn language how to do that programmatically. So SQL language, 4 basic statements in SQL language are the following: select, insert, update, and delete. And we are going to start from select. Select is essentially the synonym of give me information. It's basically, if you're issuing a select statement, select command, you are telling database give me. Okay? But when you're saying give me, you have to be very specific. You have to indicate to the database what exact information you're looking for. So that's why you have to provide additional information. So the syntax, the template for select statement, I would suggest you to write it down, because we are going to use it a lot. We're saying select and then space, and then we say what we need, what is to be retrieved. So what is to be retrieved is basically one or more fields listed by separated by commas. For example, if we need to list first name, we say select first name. If first name is the name of the field. If the name of the field is location, then it should be select space location. Okay, you have to say, we are saying what you are retrieving. Besides that, you may realize that we have several tables, and these tables may have identical fields. So if you say give me first name, that might be collide with other tables' first name. So we have to be very specific and specify what exact table we are querying. So that is done using this keyword from, which allows you to specify a table. So in that case, if we are querying employees, that will be from space employees. Okay, that's the syntax of the select statement. It will be select first name from employees. Okay, it's actually close to the English language, so it's pretty understandable. So let's do that. Let's execute this statement. In order to execute select statement, we have to navigate to the database again. But right now I'm located in object browser. You see that upper left corner? It says home object browser. We are not executing statements here. This object browser is basically for browsing the objects. What we need to do, we need to go back to home, clicking on home, and we are located at home now. We need to click on SQL button here. And as soon as you click on SQL button, you'll be navigated to this page which says home SQL, and we need to click on these SQL commands. When you click on SQL commands, you'll be navigated to SQL commands window. This window consists of two parts. First part is the window where you type your statements. Okay, select whatever statement you like, and the results will appear here in the bottom window. Okay, so let's do that. Let's execute our first command. I'm saying select. So first name from employees. It's not. It's basically I'm typing capitalized, so it will be easier for you to see. Okay, but it's not. So as soon as I type this statement, I am clicking on the run button, and what I expect to see here, I expect to see list of first names. How many records should I expect to see? How many results should I expect to see?
No, because it displayed 10.
I can say 100,000. If I click on run, how many results should I expect to see? No. Number of records should be matched exactly number of employees. Okay? That's my expectation, but should not exceed. If, for example, there are 10 people working for the company, I should not expect that 15 records will be retrieved, right? Yeah. It cannot exceed number of employees. It can be less, but cannot exceed that. So if I run it, you'll see that I get a list of employees here listed here. Exactly in order they're stored, okay? Just make sure that you have the same result set. And observe that result set has the title of the field, the first underscore name. Okay. If you see an error, Oracle error here, it means that you have error in the syntax. Okay, typo in the syntax. Success? Okay, so this is basically our first statement, and it's successful. We retrieved first name of from employees. Basically, we are getting list of employees' first names. Okay, so next let's go move forward. So this is how we execute it, and this is a template for a select statement. Now, if we need to retrieve several fields, like for example, if we need to retrieve first name and last name, okay, that's for example, I like to retrieve first name and last name. What I need to do, I need to go and modify this statement saying first name, comma, last name. So you list fields separated by comma. In this case, how many records should I expect to see? Same number. So this is actually very important. Before executing the statement, you have to ask that question to yourself. How many records should I expect? In many cases, you can get answer. In some cases, you cannot. Okay? But in some cases, if you can get the numbers and then the result set mismatches that number, it means that there is some problem there. Okay? So that will be easier for you to track down. Okay? So in this case, I expect to see the list of first and last name, and then if I run it, I get actually first name and last name, and then in this case I see complete personal information. So first name and last name. Okay, not only first names. Again, number should be the same, and visually inspecting these values, I see that all people or employees in the company, they have first name specified. Okay, so there are no missing values there. So again, number of records retrieved is 107. That's how many employees are working in the company currently. Okay? Make sense? Now, what if I need to retrieve all information like ID, employee ID, first name, last name, phone number, hire date, and basically everything in. So in that case, I can substitute this listing of fields by star. Star means basically retrieve all fields. It's actually a shortcut, otherwise you'll be doomed to type all field names separated by comma. And if I run this, I will actually get the whole table. What I did actually, I virtually recreated the table, because this represents a table, but it's not a table itself, it's a result set. These are results, it's not a table itself. But it looks like a table, right? So it's very easy for you to recreate a table. So keep this statement in mind when you're going to do exercises, okay? So it means that you can always go back to the employees tables and recreate it. See how it looks like, okay? So in this case, you'll see that all fields are retrieved. Okay, so question? No, all clear? So go ahead and execute this statement just to virtually recreate the following tables: employees, departments, and the job history.